In the previous video on surface area and volume, what we tried to understand was if there is a new dimension called velocity or speed with which the water flows through a pipe, what would be the time it takes to fill a tank. In this video also we are going to look at some similar problem but slightly different. There will be a little twist, the different way of approaching the same problem, and at the same time we are going to add another dimension to it. Here we are also going to have the cost involved. If the water is flowing at a certain speed and it fills a tank which is of so much volume, if the rate is so much, then what will be the cost involved to fill that entire tank which has got certain volume, right? So we are going to solve two problems here. One is how much time it will take to fill a particular tank, and then the second one would be what would be the cost involved. All right, so let's look at the problem now. A farmer connects a pipe of internal diameter 25 centimeters from a canal into a cylindrical tank in his field. Okay, the tank is 12 meters in diameter and 2.5 meters deep. If water flows through the pipe at the rate of 3.6 kilometers per hour, in how much time will the tank be filled? Also find the cost of water if the canal department charges at the rate of rupees 0.07 meters, 0.07 rupees per meter cube. We have a pipe. So let's assume this is the pipe, and we also have the tank. Now let's try to put in the dimensions of the pipe and the tank provided to us. All right, so this is the pipe that we have, and this dimension, right? This dimension that is given to us is 25 centimeters, right? So let's say this is 25 centimeters. All right, what else do we have here? We also have the tank, which is 2.5 meters deep, 12 meters in diameter. Okay, now before we dive deeper, let's understand one thing here. Whatever water is flowing through this particular pipe, right? We have water flowing through this pipe. That is exactly what is getting filled in this tank. Correct? So the volume of this tank would be the same as the volume of this pipe, right? Whatever volume flows through the pipe only gets filled in the tank. And once the tank is full, we are going to stop the pipe functioning, right? We are going to close the pipe. If we just try to equate the volume of the tank with the volume of the pipe, that should be good enough for us. Volume of water in the tank equal to volume of water flowing through the pipe. So whatever volume we have flowing through the pipe is going to be the same as the volume of the tank. So first let's try to find the volume of the tank. Volume of tank equal to pi r square h. So pi, let's keep pi as it is for now, because we are going to equate that with the volume of the pipe. So that pi of the tank and the pipe will get cancelled. Pi into what is the radius here? Radius given to us is 12 meters, right? So 12 meters, in fact the diameter is 12 meters, so the radius will be 6 meters. So pi into 6 square, and what is the height? Height given to us is 2.5 meters. $90 pi and meter cube. The unit will be meter cube here. So this is the volume of the tank. Now let's try to find the volume of the pipe. Now we have the diameter of the pipe given, but we do not know how big this pipe is, right? We do not know this distance or the height or the length of this particular pipe. But what we definitely know here is the water is flowing at 3.6 kilometers per hour through this pipe. So let us assume that this pipe is 3.6 kilometers long. Although that is not the case here, but it is just for assumption. In 1 hour, the water would have flown 3.6 kilometers. That is the entire pipe. Water would have flown through the entire pipe. So in 1 hour, the volume of water flowing through this pipe would be pi r square h. In this case, would be pi. Then we have 25 by 2, since this is the diameter. So pi 25 by 2, the whole square, into the height, which is 3.6 kilometers. Again, we have to convert everything into one single unit, either it is meters. Since here we are using meters, we will continue to use meters here as well. So 25 centimeters, we'll convert that to meters, and 3.6 kilometers will also be converted into meters. So in 1 hour, we can find the volume of the water flowing through this pipe. Right? Now, let's just imagine. Of course, we have already calculated here 90 pi, but let's assume the volume of this tank is 100 meter cube. And the volume of water flowing through this pipe in 1 hour is, say, 50 meter cube. Then how long will it take for this pipe to fill this tank? It would take 2 hours, right? Because in 1 hour, it just passes 50 meter cube of water. And that is not enough to fill the tank. So it would take another hour. So how did we find how long it takes to fill the tank? We just equated, we just took the ratio of the volume of the tank and the volume of water flowing through the pipe. So what we did is we just did 100 by 50. Similarly, supposing the volume of the tank was just 75 meter cube and the water flowing through this pipe is 50 meter cube. It remains as it is, right? The same thing. Then how long will it take to fill the tank? It would be 75 by 50. So it would just take 1.5 hours, right? So if we just find the ratio of the volume of the tank and the volume of the pipe, we will know how long it will take to fill the tank. I hope this point is clear. Now, with that assumption, let us try to equate this particular problem. So volume of the tank is 90 pi and volume of water flowing through the pipe is equal to, again, pi r square h, which will be pi into radius is 25 by 2, that is in centimeters. So if I have to convert that into meters, I have to again multiply by 1 by 100 or divide by 100 square and h. Now h here is 3.6 kilometers. This is not exactly h. This is actually the speed. So speed is given to be 3.6 kilometers per hour. So what we can do here is speed is equal to distance by time. Distance here in this case is, say, h, which is the length or the height of the pipe. So speed equal to distance by time. So distance equal to speed into time. Right? So instead of distance, we can just multiply the speed and time there itself. So h here, this particular h, we can now write it as speed, which is 3.6 kilometers per hour. 3.6 kilometers per hour. If I have to convert that to meters, I have to multiply it by 1000. So I have got the speed. Now I have to multiply it by time. So let's say the time it takes is t. I do not know t. So I'll just put that as t. So this thing is nothing but the height or the length of the tube. Again, this is just assumption. We are not saying that the pipe is 3.6 kilometers. It could be a small pipe. water just continues to flow at this fast speed of 3.6 kilometers. Whatever is the volume of the pipe would be the volume of the tank as well, right? So just for comparing like to like volume of the tank and the pipe, we are using this equation. Now once we equate this, so this is equation 1 of the tank and this is equation 2, the volume of the pipe. Now if we equate this, what do we get here? 90 pi is equal to pi into, okay, here 25 4s are 100. So this becomes 1 by 8. 1 by 8 whole square into, so 3.6 into 1000 will be 3600 and t, right? So pi and pi cancels out, 1 0 here and 1 0 here cancels out, and then we have 940, so 360. Now if we just do a cross multiplication, what do we have here? T is equal to 8 square, let me just put it as 8 into 8, divided by 40 goes to the denominator. So 8 5 is 40. So you have 8 by 5, which is equal to 1.30. So 1.6. 1.6 would be the hours that it takes to fill the tank with water. So what we did here, we just equated the volume of the tank and the volume of water flowing through the pipe. And in the volume of water flowing through the pipe, the edge or the distance or the length of the pipe, we just replace that with speed into time. Alright, this is just another way of solving this equation. Now that we have found the time it takes to consume, time it takes to fill the water, what is the next question that is being asked? Find the cost of water if the canal department charges at the rate of rupees 0.07 per meter cube. So cost is 0.07. Cost equal to 0.07 rupees per meter cube, right? So how can we do this? What is the volume of the tank? Volume of the tank is equal to 90 pi, right? We have 90 pi. So 90 into, now we have to put 22 by 7 here. So for 1 meter cube, if I purely go by what is the cost given, for 1 meter cube, it costs 0.07. So for 90 pi, 90 into 22 by 7, what would be the cost? We just have to cross multiply. So it will be 90 into 22 by 7 into 0.07 is written as, or can be written as 7 by 100. Right? So 7 cancels. 1 0 here and 1 0 there cancels. So 22 into 9 divided by 10. So 22 to 9, how much will that come to? Let us do it here. Rough calculation. 22 into 9. 9 2s are 18. 9 2s are 18, 198. So it comes to 198 divided by 10. So it will be 19.8 will be the cost involved. Right, so 19.8 I and R would be the cost of water that has to be paid to the canal department. Alright, so I hope you found this tutorial useful, where we now try to add another dimension, which is cost, and we also try to find another way of finding the time it would take to fill a tank if the water is flowing at a certain speed through the pipe. If you are finding my tutorial useful, please do like and subscribe to my channel so that you get immediate update as to whenever I update new videos. And if you have any questions or suggestions, please do post them in the comment section. And if you want me to create any videos on a specific topic or a concept, again, do let me know in the comment section so that I can create fresh videos on that. So I just tried to come up with a different approach here because I did see that there are other approaches of solving this problem that are already available on YouTube. So this is a slightly different approach where we are trying to equate volume with volume straight away, and whatever is the missing chunk here, we are just trying to replace that and get the value. All right, that's all I have in this video. Let's connect again in the next video solving another problem statement. Have a great day. Bye.